So good morning, everybody. I am Mauro Pezzè. I'm the director of this master, and I'd like to welcome all of you. I'd like to thank you all for being here with us. I know that there are a few of us in the room. Many of us are on remote links. They are on Zoom. This is the new setting which we came up with for many reasons. Actually, I think COVID is one of the reasons. COVID doesn't allow us to actually be all together all the time. But I think it's much more than that. We are starting a master which is not a traditional master. It's not a master that is actually come to class, lectures, go back from class. Is a master that is offered worldwide. Worldwide means not only that we are coming from everywhere in the world, but also that we are actually sitting everywhere in the world. So we will see, starting from today, which is our very, very first lecture, but we will see during the weekend, during the semester, that we actually go ahead with something which is not just sitting in the room, not just studying outside, but is working together in the contemporary and future fashion, which means, tomorrow, when you will be working in companies, will be working in leading industry, will be working in leading universities, it's going to be less and less the case that you will be sit all together in the same room. And I think it's important, it's part of the learning experience. So it's not just COVID. COVID actually is a sort of excuse to start in this way, to have mask of our few people, who brave people who actually show up with us, but it's really something which is more than that. And that's actually why we also do not worry too much about being able to access Switzerland during this time. Some of you may not be able to access right now, but this does not change at all, and you will be free every time in the master to move on with different kind of settings. Every student should be able to be sitting whenever is more comfortable for their life, for their study, for their participation, and work all together for the master. But I think, this is also sort of a bit of emotional time, because, this is the very first time. It's not just the first day of this academic year. It's the first day ever where we have master students in SIT. And this is a big step forward. We started less than a year ago. And I remember in December, when I actually pushed to get this master starting, I got this skeptical reaction, say, come on, who can start a master with like 9 months ahead? And we did. We are doing today, and this is a great news. Now, this is a sort of welcoming lecture. So it's not a traditional lecture, although the setting will be mostly the same as we will have in the lectures, because it's important. In the lecture, we will have a more dynamic setting than today. Today is more like a sort of, we have to speak. And the difference from other kind of lectures, we do have, we start with a set of invited speakers. So we have a few keynotes, let's call them like that. So we have a few people who will actually give you a vision of not only the master, not only the new institute, but also the city and the canton who host us, which is very important for us. Okay, we are international. We have students coming from all over the world. We have students who will be sitting all over the world, but we are in Schaffhausen. We are in Switzerland. We are in this canton that gives us also this foggy Swiss time. For the first time, I've been here for like almost a year, and this is my very first time I get this really Swiss taste foggy day of the environment. So we have Bertrand Meyer. Bertrand Meyer is our provost. Okay, I tend to say Meyer because Bertrand is French, but I know he actually would name himself Meyer in the English way. Bertrand is our provost, and he will actually give us a sort of bird's eye view of what is teaching and what is learning, what is the education experience in SIT, what is and what will be. Okay. Then we have Sergey Belusov. Sergey Belusov is the mother of SIT. He's the person who actually created this environment. He's the visionary person who actually thinks believes that we can actually build a completely new top university worldwide from scratch. I think, if nobody trusted me when I said I want to start a master in 9 months, even fewer people trusted Sergey when he said that he could actually start a new university in Switzerland, the top country for education, and be better than the top country education universities. We are not there yet, but we are approaching very quickly. So maybe in a few years' time, we will be the top university in Switzerland, which means also in Europe and probably worldwide. And Sergey will tell you something about his vision. Sergey is a visionary person. He's some people, one of these few exceptionally people who can actually really tell you, we will do this in 5 years, in 10 years, and he does it, and will tell you what the future of computing is in his vision. And then we have Peter Rost, who is welcoming you from the canton, because I said we are international, but we are in the canton, and I think it's really important for the people sitting in this room, for the people sitting in Moscow, sitting in Singapore, sitting in Brasilia, sitting in New York, who are with us today. It's important for them to actually feel that we are in Schaffhausen. And we like to actually, and we are very glad that the cantonal authority are with us to welcome all of you for this special event. And now let me hand over to Sergey, to Bertrand for the introduction of the.
We've had students in partner universities, the National University of Singapore and Carnegie Mellon University for 2 years now. But this is the first time we are hosting our own program, thanks to, in particular, Professor Pedze's vision. This is going to be not quite your standard lecture. So in particular, it's going to be quite interactive. So I'd like to, we are going to learn to use it. This is quite new, but if you see this, which I hope you do, please say what it does. Go to 1346, so go to menti.com, MENTI, and use the code 1346014. And I'm asking you a really fundamental question, which is what is your hair color? And I apologize. So this is one case in which the students who are on site are actually at a disadvantage. Oh, it's working. I have one black-haired person. So there's only one student so far. I thought we had more than one student. Come on. So menti.com, 1346014. Oh, okay, now it's coming. Okay, it's working. So this is not the only tool we're going to use, but you know, you have heard already, and you are going to hear much more in the future about blended flip learning. And we're not going just to deliver lectures to you. We want the whole thing to be interactive. And Menti is just one of the tools that we're going to use for this. Of course, there are many more sophisticated ones, but I can see a strong dominance of black-haired people in this group. We are going to have to adapt our teaching correspondingly. I have actually talked to to many of you, I think most of you. So my second question is, if you're a student, so if you're not a student but still attending this presentation, don't answer this particular question, but just out of curiosity, did I interview you on Zoom? So I have a feeling that we are a family here, and I interviewed something like 110 students over the past 2 months. So 5 of them are admitting it so far. Again, it's the same code, right? But it's the next question. Well, okay. So we know each other, right? We have been seeing each other for a while already. As Professor Pedze already mentioned, the idea of SIT comes from the vision of Sergey Belusov, who is going to speak immediately after me. And the general idea is to have a core here in Schaffhausen, which is the headquarters, but also the intellectual and scientific and educational center of the whole SIT enterprise, what we're also going to call the SIT zone, with tentacles just in many places in the world, and we're planning many campuses. But of course, the heart of the action, the core of the action, is always going to be here. So what is SIT? The basic model that we're following is what is known as the Humboldt model. Is the research-led university. It was maybe not invented, but formalized by Wilhelm von Humboldt in the early 19th century, But it's the model that you have behind the world's most famous universities, from Stanford to Carnegie Mellon, but also Oxford, EETH or EPFL in Switzerland, and many others. So the Humboldt's idea was to say, well, let's not just have institutions of learning as we have had, at least in Europe, since the Middle Ages, and also in the Middle East, for example, or we can go back to ancient Greece. But let's bring together under one roof, both one physical roof and one conceptual roof, the best students, the best teachers, the best education, and the best research. Everything going well together, and these various streams somehow feeding each other. You know, the best researchers teach, and even if they're teaching elementary topics, their teaching is influenced by the leading edge research that they are carrying out on in the rest of their time. But it's not only one way. It's not just that the students benefit from the best, most up-to-date teaching. It's also that the professors benefit from young minds, young, creative, inquisitive minds, and questioning minds. You know, one of the secrets of good science is that you never rest on your laurels. You know, you can have 2 Nobel Prizes, 3 Fields medals, but the next sentence that you express, the next theorem that you claim to be a theorem might be completely wrong, and a 25-year-old PhD student or even a graduate student can actually say, you know, sir or madam, 2 + 2 is not equal to 5 as far as I remember. So it's really both ways, you know, both the best professors, the best researchers imparting their knowledge and their experience to the younger generations, but also the younger generations questioning and bringing new ideas, and not always taking the answers that they're getting as definitive. So this has worked extremely well. A large part of the success of the modern world is due to the success of these top universities, including some of those that I cited earlier, and many others. So this is a system that has developed over the past 150 years. Of course, it goes back much further. It goes back to the Sorbonne and Bologna and all the medieval universities, but it really took shape in the 19th century. You know, you take ETH Zurich, for example, 1855. This is the time when many of the polytechnical universities in particular were created. Polytechnique in France is a little bit older. It goes back to Napoleon. This is about the time when it was started, when this model was started, and it took shape over the next 150 years and really came to dominate the successful parts of research and education, with its rules, its structures, you know, in particular the academic curriculum, the gradus ad parnassum, bachelor, master, PhD, you know, the immutable order of things. Also the notion of academic governance, which basically means that no governments or sponsors give academics money and more or less let them wash their dirty linen between themselves, or their clean linen, as we hope will be more often the case, make their own mistakes and basically run their own business. So this is a fantastic model. As I said, it has worked very well, but it also has shown its limits. It's all rooted in 19th century tradition. Some of them, as I said, go further back. I could also have mentioned Harvard, which is one of the most famous ones, and which goes back to the 17th century. You have strict boundaries between disciplines. You know, there's the Department of Physics, the Department of Computer Science, the Department of Mathematics. They talk to each other at the faculty club, but the interdisciplinary collaboration remains very much a stuff for speeches. It doesn't happen very much in practice. You know, everyone talks about multidisciplinarity, but in practice, it's very hard to cross these discipline boundaries. And this is one of the things that we want to do better at SIT. At this point, we don't have departments. We don't expect to have departments in the short term. We're going to have chairs, but you know, it's very important for a physicist to be able to talk to a software guy, to be able to talk to an economist, and so on. So the rules are quite constraining, as you can imagine, after 150 years or more of bureaucracy defining the rules. Of course, bureaucracy is good, rules are good, but they can be too constraining. So you have institutions which are not always as flexible as they should be. They're not enough focused on innovation. They have links with industry, but it's always a difficult partnership between universities and industry. They have been slow to react to societal change, and also they're very much self-reproducing. You know, best students do a PhD, the best PhDs become assistant professors, the best assistant professors, best in the sense of the institution, become full professors. So you have very much a kind of self-perpetuating cycle, which is not so good for innovation. So what we want to do at SIT is to retain the best of this fantastic model of the Humboldt University, but go beyond and remove the not so good aspects, and in particular benefit from other models, because this is not the only model. You have the academic model, sometimes called the Soviet model, but it doesn't just exist in the late Soviet Union. It exists in countries where you have, on the one hand, research institutions like CNRS in France, or CNR in Italy, or the National Institutes of Health in the US, which do just research. And then you have educational institutions, the traditional universities. And this model has something to speak for it as well, but it hasn't been as successful as the Humboldt model. So you have education-only institutions. There's also a lot to be gained from the model of industrial research laboratories. For example, the mythical, legendary Bell laboratories have been, which don't really exist in any reasonable shape anymore, but in the middle of the 20th century, Bell Labs was at the origin of many of the of the innovations that have really shaped our world, from the transistor to Unix. And I should also have mentioned Xerox PARC, where much of the Palo Alto Research Center, where much of the modern IT has started. So we want to get the best from all of these models. So we want, our base model is Humboldt. We want to get away, not maybe from the structures, or some of the structures, but more importantly, from the strictures, the constraints of traditional universities. We want to be always focused on innovation, to develop close ties with top institutions worldwide, starting with our current partners, NUS in Singapore and Carnegie Mellon, but there are many other partnerships under development. We want to develop close ties with industry, local industry, starting with our own network and worldwide. We want to foster innovation at every step. Listen to everyone, you know, listen to the first-year master students, as well as to our partners. We want to take advantage, and we want you to take advantage of the SIT ecosystem, what we officially call the SIT zone. We're starting with Acronis, which is the company that has really started SIT, but there are many others in our ecosystem. We want to be quite topical and timely. We of course all living under the COVID situation. Of course, it's a big obstacle for all of us, but it's also in some ways an opportunity. In particular, it makes it possible. It gives a real opportunity to see how we can best combine local and on-site and remote teaching, and how we can best take advantage of the fantastic communication technologies that we have today. And we want to develop our own specific learning technology. So later on today, you will hear a presentation of Alimera, which is our own partners, Alimera's effort to develop a comprehensive learning management system, and in general education management environment, which we will actually start using for our own courses as well. By the way, just as an aside, I'm interested to know in what country you are. I more or less know it, but I think it's really important it's really useful to see it. So please, as I'm talking, type in the name of your country here. As one of the characteristics of SIT, and in particular of this class of students, is that it's kind of mini United Nations. It's about as diverse as it can get, and this is something that you will never find in a traditional university. For example, when I'm talking about getting out of the strictures of traditional universities, many of you many of the students who are here virtually now have a bachelor's degree in a field other than computer science. Well, it's not a crime, right, to have a bachelor's degree in mathematics or economics. But in traditional universities, including some which I know very well, it's a no-no. If you have, for example, you're interested in robotics and you come from mechanical engineering, you have a bachelor's degree in that field, and you want to do a computer science master's managed by the computer science department is not going to accept you. They're going to say, oh no, you don't have enough background in computer science, or they're going to impose to you a year of retraining and so on. We cannot afford to do this kind of thing. And of course, we're taking some risks by accepting some of you whose background in computer science is relatively shallow, but we hope that it will, and we know really that you will compensate for that by your intelligence, by your experience, and by your knowledge of other fields like mathematics, for example, which are extremely important for computer science. So, okay, this is the word cloud of origins. It's actually not origin. I asked in what country you are now. It's one criterion. I could have used another one. We can see a fairly substantial Russian contributions of Privyet Siam, but you can see the diversity that we have here, and this is only possible thanks to the extremely flexible model that SIT is proposing. So a few words before I leave the word to our founder, Sergey Belusov. A few words about our research. So the overall plan for the future is to have as light an administrative and bureaucratic structure as we can. Of course, we will have to establish maybe at some point departments, the later the better, and some structures. But basically, we want to have a fairly flat structure with chairs. You know, the chair is the unit of research, and the chairs are going to be divided into three general categories. The first one is computer science, software engineering, information technology. It's the blue part on the left. So IT, if you like, as in general. Then physics, with a particular emphasis on quantum technologies and advanced materials, with lots of opportunities for multidisciplinary collaboration between these people, our friend the physicists, and us, the software people. And then there's a whole area which is technology transformation and entrepreneurship, digital law, digital business, digital sports, and each research chair is typically manned by a full or associate professor, an assistant professor, and then a number of PhD students and postdocs, that is to say, more junior researchers. And we have already started to create such teams, as we'll see in a moment. So this is the overall scheme that you might have seen in some of our presentations, in which from the research funding, the students, all this incredible brain power that we get, we produce through research, spin-offs, new IP, patterns, technologies, and of course, we provide the industry with professionals. And I'm not going to go into the details of this because Mauro Pezze will present the master in more detail in a moment. A couple of words about our partners. Carnegie Mellon University, which is of course one of the most prestigious technical universities in the world, and National University of Singapore, which is a fantastic model for us because, you know, 30 years ago, Singapore was scientifically and educationally a backwater. And if someone had mentioned NUS on a par with Stanford or ETH, everyone would have laughed. Well, no one's laughing again. In 30 years, in less than 30 years, NUS put itself at the very top of the hierarchy. You know, in the rankings, it's typically in the top 10 or 15, and it's a fantastic model for us because we also want to grow very quickly and reach the top ranks very quickly. A couple of words about our research. So at the moment, we only have 2 professors. This is very small, but our ambitions, of course, are very big, and we will be hiring more faculty in the coming weeks and months. So Mauro Pezze will talk about his own research. As far as I'm concerned, my work is in software engineering in general. So I have quite a broad set of For example, at the moment, I'm writing a book on requirements engineering, how to help people produce good requirements, the description of what software systems must do before we ever write the systems. But I also have an interest in programming languages. You are going to be exposed soon to the Eiffel programming language in which I've been involved and which we will use for my software construction course. I'll talk about this later on. But a particular focus of my research, which is really what I'm intending to do here at SIT, is software verification. So the federating project for my chair is the software analysis factory, which is a kind of general engine to find problems and correct problems in a program. So the inputs are programs, questions that we ask about the program. So for example, is this program going to produce a buffer overflow? Is this program going to produce a null pointer dereferencing error? All kinds of, any question that you ever want to ask about the program. And the engine is going to produce answers. What makes this more complicated is that you have a third parameter, which is the language, because we have such a variety of languages and tools and environments, from JavaScript to Python to Java to Eiffel and so on. So we need to be able to parameterize it. So this is the work for several years and a number of PhD theses, and I hope many papers, and not just papers, but software products. And it's the federating project for our chair. So as a conclusion to this presentation, let me give you a few words of advice, because it's going to be tough, and it might not even be obvious right away that it's tough, because we're going to start smoothly. For example, in my class, we are going to start, relatively gently. There's in my career as a student, I experienced two modes of education. The European one, at least the French one, through which I went, and the American one at Stanford. So in a French class, and I think this is more or less the case in European universities in general, when you get into a class, you have a certain number of prerequisites. You assume to know them, and then it goes relatively regularly. Then I went to Stanford, and I remember very well taking a course on on linear programming. Sorry, not dynamic programming, but linear programming, by the creator of that very important technique, Georges Danzig. And the first two lectures were absolutely trivial. The European students in the class were actually laughing, because we are going through very basic linear algebra and so on. And we all said, oh, this is kindergarten stuff. These Americans, they don't know anything. And then we stopped laughing, because the curve was rather steep, in the proper sense of the word, steep curve. People always say a steep curve, I mean it's long. To learn, it's actually the reverse. If it's steep, you have to learn very quickly. And I can tell you that in the second or third week, we were not laughing anymore. So it's a little bit like what is going to be here. And don't be fooled. For example, for my class, if I tell you that things that you think you learned in kindergarten or even before, it's not going to be, at some point, you might also stop laughing. So attend absolutely everything, all lectures and labs, show both humility, in particular, in software engineering, what I noticed in my interviews of you is that many of you have some kind of basic approximate knowledge of the fundamental concepts, but one shouldn't push too hard. And it's very important to have precise understandings and rigorous scientific understanding of all these concepts, for example, of object-oriented programming, class, inheritance, polymorphism, and genericity, and many others. So you need to have some humility. You accept going through things that maybe you think you know, but maybe you don't know them as well as you thought you did. And critical thinking, of course. Anything can be questioned, right? Ask questions, take initiatives. Don't wait for us to tell you everything that you need to do. Look for projects. The SIT curriculum is going to be very much project-oriented. So we will provide and propose some projects, but don't necessarily wait for us to propose a project. If you have something of interest to you, then come to us and suggest a project. And I'm not promising that we will always say yes, right? If you want to count the number of swans in the Rhine, which you don't see, but which I see, to me, I don't think this is a very interesting project for SIT. You may go to Professor Petze for this project, but so we're not going to accept absolutely everything, but don't be shy, okay? take advantage of this SIT ecosystem. We have many partners, many companies with and other partners with which we are in contact, from SIT, Acronis, Alimera, SIT Autonomous. Take advantage of all these flip learning mechanisms that you're going to discover little by little. As I said, it's not going to be just traditional lectures, but it's going to be very interactive. I should also warn you that not everything will be perfect. It's the first time. Okay, we have not done this before. I mean, many of us have done this in other environments, but never, we have not done it as SIT, and we are trying something quite new, which no one has quite exactly done before. So there's going to be a few hiccups. So shout at us, but don't hold grudges, right? Complain, exercise your critical thinking, but make do with what we have. So. Welcome again to beautiful Schaffhausen, and this is a great opportunity to now give the word to Dr. Sergey Belusov.
This is Sergey. One of the things about starting a new project is people think it's taking risk, but in reality, one of the things is to tell the same speech about 100 times. So this is about the 100th times I'm saying this speech, and considering the audience is mostly students of SIT, I assume I will try to be very brief. So first of all, about Acronis, which is a company I'm running right now. And as we know, computers and software are eating the world. Everything in the world is digital. And digital workloads are very easy to destroy and to modify. And so they need to be protected. And that is very, very complex now because there are so many workloads in so many places. It's also very expensive because there is a lot of data and a lot of workloads. It's also always an issue of making sure that you can protect them from security threats, because security threats are happening all the time. Every day there are 300,000 new viruses. Every day there are some companies which are penetrated with ransomware or with other dangerous threats. You also need to always worry about privacy, and today nothing can be done without IT. As we learn, there is a significant similarities between biological and computer threats. And with biological threats, you need to do prevention, detection, response, recovery, and forensic in order to stay safe. In places where this particular situation with COVID, for example, is managed well, like Singapore, that is where all of these 5 things, prevention, detection, response, recovery, and forensics are done. And that is very similar for computer threats. You also need to do prevention, detection, response. You also need to do recovery, because sometimes you do miss some attacks, and then you need to do forensic not to get the attacks repeated again. And that's what we do in Acronis. In Acronis, we provide integrated and autonomous cyber protection, making sure that nothing is lost. So making sure of safety, making sure that your IT is accessible from any time and anywhere, making sure that you can control who has access to your workload and to your data, making sure that your data is authentic and is not modified. You can check at all the time that the data is the same, and making sure that you are protected against bad guys. And with that, we provide the main and only product of Acronis, Acronis Cyber Protect, which is available as both cloud service and on-premise product, available through Acronis Cyber Cloud, through the network of 15,000 resellers and 30,000 service providers. It's extendable with Acronis Cyber Platform. You can actually extend Cyber Protect and Cyber Cloud. It is based on Acronis Cyber Infrastructure, which is specialized computer, software-defined compute storage and network designed for protection, very cost efficient, very controlled, very reliable, and extended by Acronis services. Acronis is based in Schaffhausen, just like SIT. That's how I ended up starting SIT in Schaffhausen, and it has a second headquarters in Singapore. And today we have people talking to you both from Singapore and Schaffhausen. And it's a medium-sized company with about $300 million in revenue, growing very rapidly to several $billion in revenue in 5 years, which is already a significant software company. Interesting for people who start the program this year because it's a company which builds a platform. And we have these very specific areas of expertise, cyber protection and cyber engine based on artificial intelligence, very significant investment in AI, deep learning and machine learning, both hardware and software, computer science, software engineering, education. We have over 50 million lines of code in Acronis, and Acronis is not just an application, it's an infrastructure software, and it is also a platform, so it's extendable. And it's designed like a platform designed to service billions of workloads. And we also have very specific expertise in business science, sport technology, with Acronis CyberFit program, where we apply artificial intelligence to replace human in such interesting fields like sports. So enough about Acronis. So why SIT? There are some real-world problems which are still present in front of us, and they need better software and better computers. This is an example of some of the problems to solve. For me, most annoying is diseases and aging. The problem which is definitely solvable, but is solvable through interdisciplinary approach, applying life sciences, computer science, software engineering, perhaps some advanced physics and business sciences, but also some other problems. As we know, universe is a computer, and so better computers can be used to predict the universe. All the newest vaccines. A couple days ago, I had a dinner with a chief scientist of GlaxoSmithKline, which is the largest company in vaccines. They produce the most vaccines in the world, and they have largest revenue in vaccines. And he told me today there are 365 vaccines in different times or different types of clinical trials for COVID-19. Almost all of those vaccines were designed using computers. So what is a computers? As you know, computers are effectively equivalent to Turing machines. So these wonderful new generation computers, which are based on central processing using graphic processing unit or tensor processing unit, they're all actually effectively equivalent to Turing machine. Turing machines are 1D. Current CPUs on your computers are 2D. There are new CPUs which are 3D. There is no more 4D. And so really there is limited amount of acceleration possible with computers. So there are new generation computers coming, which are still digital, based on neuromorphic designs, like this particular Intel Lohi chip or Cerebras chip for neuromorphic design, which is around 1.2 trillion transistors on a single wafer, which is a huge number of transistors, many times more than on a traditional CPU. There are new generation designs which are based on memristors, which is something slightly different from digital computer with some element of randomness. There are photonic computers which allow much faster, much higher clock speed and much lower power consumption. But ultimately, all of these are digital computers. The digital computers are really limited in how much processing they can do. There is this guy, Gordon Moore, who formulated Moore law some years ago, which is an observation that digital computers are getting, they double in number of transistors on a chip every 24 months. There are performance and throughput problems, power and consumption problems, transistor size problems. And so ultimately we're reaching fundamental hard limits of digital computers in somewhat 25 to 75 years from now. And you may think that we are still very far away from getting to a limit of what we can actually count or what we can actually compute on those computers. But in reality, there are these two very simple problems, many-body problems in physics, which is effectively being able to predict the behavior of matter, and for example, large integer prime factorization, which is what the public key encryptions are based from. You can easily come up with a problem which cannot be resolved on any digital computer ever. And so for that, there are new generation computing coming. This is a picture of Google record-breaking quantum computer, which was able to achieve quantum supremacy, effectively calculating this rather artificial problem, but nevertheless much faster than on any classical computer. And so there are these interesting designs, which are not digital computers. There are quantum computers. There is 3 leading designs called atoms computers based on Rydberg atoms, ion traps, and superconducting qubits. There are some futuristic ideas on making computing on the surface of black hole that may take some time before we get there. And of course, you can also make computers on advanced materials. All these computers, when we design them, we should always remember that in the brain of humans, in our head, we have some very interesting advanced material computer, which we still do not completely understand how it works, which is based on starting from human DNA. So human DNA is 200 billion atoms. You put it in some very special environment and it will grow into 40 trillion cells in a human body, which ends up with 100 billion very large neuron cells in our brain with about 100 trillion brain connections. And it is only 1.5 kilo most of the time and only 10 watts of power. Nevertheless, it has some rather superior learning capacity. And we really are not currently in a full understanding how brain works. And so on this slide, I typically pose the 3 questions. One question is, do we know all the physics required to understand a process in human brains? Do we understand all the physics needed to understand human brain? And does physics even remain the same in the presence of a super powerful human generation device? There are many ideas. There is quite a break between different people in science. So some people think that human brain is just a hot, wet Turing machine. So slightly more advanced than a traditional Turing machine, which you can produce today. And there are some people who believe that human brain is even beyond quantum computer capacity. So nevertheless, we have many digital computers working today. There are new generation computers needed for all these fields: robot, sensors, photonic, the quantum repeaters, advanced materials, data storage, healthcare. They require new computers. Without new computers, you cannot process further. You cannot make a fully secure internet. Everything today is very well listened, no matter which messenger you use and which security messenger you use on your phone. It can be definitely broken and listened. And the only answer to this is quantum internet. The modern robots require much better and real-time sensors. So all of this require quantum computer, new generation computers. And lucky for us, a modern world architecture allows us to immediately plug the computers into a sort of a global open system interconnect. So the future internet would include CPU, GPU, TPU, like it is today, memory, star array, photonics, and quantum computers. Very soon, already next year, we will have photonic computers, memory, star array, and quantum computers available to us from Amazon, Google, Microsoft, and other large cloud companies. And then you can imagine plugging some other futuristic designs. All these computers require new advanced materials. There was a lot of materials invented in the process of building current computers. New computers will require completely new hardware. So they are not going to be built the same way as the current computers. It took us about 70 years to get where we are with the silicon computers. They will require completely new software to design them, and that's one of the reasons for the process for the progress in present computers is the presence of very advanced software to design them. They would require new software to run them and new applications to leverage them to solve problems. So for that, we decided to build this new institution, as Bertrand mentioned, and as other speaker will mention, based on an interdisciplinary approach, designing it around computers, physics, and business in one place, designing it from the sort of the other way around, designing it around making business which enables science and education which supports business and science. And so this is really the way we design it. There are several for-profit business units which fund the non-profit university. I'm not going to stop on the slide too much. The important thing for students is that in the university, not only we want to apply interdisciplinary approach around different areas of science, but also we want to mix science, business, and education in one place, and in such ways that there is a good and healthy balance where the scientists, which are now the most important people in the world, can make money to support themselves and build business while not stopping science. This is the areas we want to focus on. We believe this is the areas which are most important in the next 10 to 50 years: computers, physics, and business sciences, specifically cybersecurity and information integrity, artificial intelligence and machine learning, software engineering as a science, robotics and autonomous machines. Also quantum technology and advanced materials, specifically functional intelligent materials, digital health, new generation, business management, digital law, digital sport, digital learning, education, and artificial intelligence and arts and design. It is such that in the future, almost any area requires application of multiple of these disciplines in order to solve real-world problems. For example, to build so much desired autonomous machines, autonomous helicopters or autonomous cars, you actually need all of those areas applied. You know, in fact, I've deleted some areas from the previous slide, but probably almost every area is ultimately required to build an autonomous machine of the future. And so how can we build a new university? It's always perceived to be very challenging. In reality, it is not so challenging because it's based on partnerships and it's based on people. So we partner with Carnegie Mellon, which is one of the top computer science universities of the world. We partner with National University of Singapore, which is one of the top universities on the world, period. And we involve those advanced people in our strategic advisory board. All of them are our board members, but not only. Also, they participate and help and spend hours and hours per week and days per month on helping the university. Kostya Novoselov is a Nobel Prize winner in physics of 2010, inventor of graphene. He's based in National University of Singapore. Michel Lukin is professor of Harvard. Nicolas Jezan is University of Geneva. This is our physics strengths. Artur Eckert, David Rosenberg, Mark Kamlet helping us with computer science. Fabio, Rino, and Sergey helping us with business sciences. And the board and executive board and industry board and SIT union, ultimately, the reason why we can't build a good master program from scratch in this year is because we have advanced people. All the master program is nothing but people who teach you and people who we are studying with. And so I'm not going to stop on this program. This year, we're only launching computer science and software engineering program. Next year, we're going to have quantum technology and business sciences master program launched. What is different about our program? First of all, it is different that we believe that in every software and every project of the world, there is software. And in the future, whether you're doing a business project, whether you're doing a technology project, or whether you're doing a science project, you're typically dealing with a medium or small or medium-sized project, which takes many years and takes many people. And so in such project, it is important, of course, to understand computer science and to understand how to write software, but it is also important to understand how to lead and manage people. And so in our project, we first of all teach people, we define those 15 roles, which are important in a large project, and we want to give you an overview in the program of these roles and how you can play inside the large team or inside the startup in these roles. And so this is eight differentiators of our program. So first of all is the involvement of those advanced people on our boards. When I studied in my university, most important thing for me was the other students, other advanced students which studied with me, and the professors who I was able to talk to. Then, of course, the fact that we're gonna try to teach you in this program on how to lead the teams of leaders. We will also teach you on how to manage change. The reality is that there is always change in technology business. Nothing is staying the same. So this is sort of a quote from Andy Grove, the person who coined the phrase, only paranoid survive. The change is the reality of this business. Change happens every 5 years or every 10 years in larger platforms. Then we teach you science of people. The reality is that in this business, it is very important to be able to understand other people. Most of things which you're gonna do in building your science, technology, or business project is to talk to people, either members of your team or people you want to hire on your team. Then in this program, we will try to explain to you business science. Business science is talking about business in the language of computer science. Business by now can be expressed in the language of mathematics, business strategy, decision science, leadership, social, organizational behavior, decision sciences, again, and programmatic marketing is something which is very useful for software engineers and computer scientists to understand. Then very basic overview of quantum informatics, advanced materials, and entrepreneurship. Part of the project is being able to participate in entrepreneurial project, and that's something we can explain to you how to do. So I wanted, this is what I prepared last time for our students. This is a good movie on the right where you can learn on how hard it is to be entrepreneur and what is to be entrepreneur. But this is my 11 qualities of entrepreneur. So high EQ, being able to understand other people. So here it's really supposed to be EQ, not IQ. Education, network, luck, hardworking, nice looking, good person, good talk to, good manager, good leader, charismatic. Well, apparently all of these qualities are not so important. And so what is important for entrepreneur is just these things: ambition, initiative, empathy, alert, responsive, detail, oriented, decisions, never giving up, frequency, passion, and care. I don't have much time to explain it here, but ultimately, what do entrepreneurs do when they go forward? And that is sort of the decision cycle. Some people think they want to do what they want. Some people think they want to do what they should. In reality, you have to always do what you can. And you can do things where you get the right opportunity and you are able to execute on this opportunity. You can come up with differentiated strategy where the strategy is different from others, where there is a application of your unique capability and you have enough focus. And the reality is that if you don't find the right thing to do what you can, you have to come back and wait and acquire more knowledge. And hopefully that is what we help you to do in the university here. And so this is my last slide. What you can do now, you can become Acronis customer partner, employee, engineer, or executive. Today we have about 1,000 technical people in Acronis. We have engineering offices in Bulgaria, in Singapore, in Schaffhausen, and so you are very welcome to consider Acronis. We're going to double the headcount in 3 years, so we will have 2,000 people. Most certainly we'll have enough interesting jobs for any of you. You can also join SAT after you graduate. You can also, of course, study in our program as you're doing it, and the goal here is to really be the best. And this is 3 examples of the people I think who have done an amazing job. Alan Turing, of course, is one of the most influential people in the history of science. You can win 2 Nobel Prizes like John Bardeen, who invented the transistors and superconductivity, or you can build a wonderful company like Google, like Larry Page and Sergey Brin, who were able to complete their master program, but they dropped out of PhD program in Stanford. Thank you.
Yes, hello. Dear students, dear SIT representatives, thank you for the invitation to this event. I'm Petra Rost. I'm working for the economic promotion of the canton of Schaffhausen. That's the canton, we are a cantonal organization, a governmental organization. I would like to welcome you in the name of the economic promotion. I would like to welcome you in the name of the economic promotion to Schaffhausen and give you a short insight into our wonderful region, as you cannot be here today. First, I would like to show you Schaffhausen at a glance. You can see it on the next slide. Yes, and the next slide, please. Yes, hello. So Schaffhausen is the top 1% of Switzerland. As you can see, the yellow spot in the north, right at the border to Germany and the EU. It is also about 1% of the size of Switzerland and the population of Switzerland. Schaffhausen is part of the Greater Zurich area, which is the driving economic engine in Switzerland. There are, in about 16 minutes drive from Schaffhausen, there are living about 3.5 million people in Switzerland and Germany, as we are really close to the border, and there is a workforce of about 1.8 million people here next to Schaffhausen. Over the last 20 years, Schaffhausen has developed into a preferred headquarters location. Today's companies like Acronis, Garmin, Citrix, and many more are located here. But in Schaffhausen, the industrial past can still be felt today. The industrial competences is demonstrated, for example, in the strong medtech and materials cluster we have here, but also in the pharmaceutical sector. Furthermore, thanks to the diversified economy, the innovative strength is still very much in evidence today. And that is why Schaffhausen is today a leading location for the development, testing, and application of future-oriented technologies, as you'd like to introduce you on the next slide. You can see the 7 focus fields we have. First, on the left, you can see smart mobility. Here we already have a platform for research and development of intelligent transport system. We also have future farming. Here we provide a network which enables agrotech pilot operations. In advanced materials, the Schaffhausen in Schaffhausen, there is the National Competence Network for Material Technology located. In the field of smart government, Schaffhausen has their first digital identity solution on a cantonal level in Switzerland already implemented and in action. In the field of smart health, we have different projects which are connecting the pharma, medtech, and the digitized world together. And the sustainable excellence topic, we focus on products, processes for a sustainable society. Here already different initiatives are going on. And of course, most important for you today, we have also the computing, science, and edtech focus, of which the SIT is part as well. They provide research, knowledge, and education in future-oriented areas at the edge of industry and digitization. An international network which is bridging between education, research, and applications for industry, which we think is very important today and will be much more important as well. And with this, we also want to remove barriers between specialities and discipline we still have today. And as you can see, the SIT and all the ecosystem around the SIT fits very well into the location promotion and the strategy of the Canton Schaffhausen we already have. I have given you some hard facts in the last couple of minutes, and I would like to give you now the opportunity to see a little more of what Schaffhausen is. And now you can see a short video which summarizes the advantages of the business location Schaffhausen quite perfectly and gives you also a little insight in the high living quality we have here in this area. And with this, I also would say I wish you good luck and a good start to successful studies at the SIT, and I hope to see you once in future here at the location in Schaffhausen. All the best for you new students.
Will you choose Schaffhausen because you'll be home from work in 10 minutes? Because your children will get to school in 10 minutes? Because you can be at your desk in 10 minutes? Will you choose Schaffhausen because you can recruit from around 1 million people within an hour's drive? Because their expertise and talent are just what you're looking for? because you can take off for anywhere in the world in just half an hour? Will you choose Schaffhausen because the traditional and the high-tech are equally at home here? Because your investment will be worth more? Because in Schaffhausen, work and exceptional quality of life go hand in hand? Will you choose Schaffhausen because it's so near? Business location, Schaffhausen.
This is the beauty of the mixed presence and remote. I'm online now. Yes, thank you very much. Okay, so let me actually, first of all, thank our speakers. I mean, thanks Bertrand for the introduction of the style of teaching and the style of education in Schaffhausen. Thanks Sergey for the visionary talk. Thanks Petra for the description of the environment. In general, you know, in a class, I like to give a space for questions, but maybe it's running a bit late. So I want to move on to a different, so unless there are really, really urgent questions for the speakers, I would prefer to go on with student time. Okay, so this is not just a forum for big people, important people to actually present new ideas, which is important. It's specifically done and built for you as students, okay? So what I like to do is I like to start working with you. So there is one thing which is important. We need to build a community, you know? So we need to have to know each other. It's difficult, it takes time. We are also a bit surprised because, you know, I've been teaching in Switzerland for 15 years and I've been starting different programs in different parts of Switzerland, and the average size of classes in universities in most of the cantons, except the very few big ones, is between 5, 10, 15 students. Now we have much more today, which is actually, we are very proud of that. I think, you know, the amount of us in the classroom today is the size, us, and if not more than the Polytechnic of Zurich, which is the biggest teaching environment, education environment in Switzerland right now. So it's going to be difficult for all of us to actually take part, but I like to ask our technical staff to move on to give me a chance to let you introduce yourself before me telling you about myself, the master, and the courses. So what we do is we have about half an hour before the break. Break are important to actually get relief. So I like to spend this half an hour to give some of you the opportunity to let you start knowing each other. Okay, so I'll ask you to share your name, where you're from, what is your bachelor about, so that we can start learning each other. And then we have more time in the afternoon, more time the next days to actually complete the introduction, okay? So we switch to the possibility of getting everybody the chance to talk. And what happens is that you simply have to raise your hand and you'll be happy, you'll be given the possibility to introduce yourself. While starting, I have a quick suggestion, if I can, since we have people in the classroom. Maybe I can ask if possible to Ishika and to Adam to introduce themselves, if you don't mind. You start this polling. So what I will do, okay, you may actually share that, okay, because you're trying to, okay.
I'm from Zurich, and my undergraduate was in electrical engineering and computer science with a focus in computer architecture.
Hello, my name is Adam Sobecki. I come from Poland, and my bachelor's was about predicting travel times of vehicles. And it's nice to meet you all.
Okay, so I have this suggestion, which is, I don't know, which is basically, you know, okay, I like to see the pictures of the people on the screen so we can share the faces, because it's actually what I want to actually have is face-to-face meeting. Okay, Anatoly, if you cannot see the pictures on the screen now, can we actually switch to my presentation? We change a bit the program, okay? I introduce the master and we start introducing later on, okay? It's a technical challenge, you know, people remotely may not actually have a feeling, but we have our technical staff with 4 laptops in front of them, and it's not easy to manage all of that. So what I like to do is I like people to introduce themselves face to face, because I think seeing the face is also important. I will give each other a chance to show your face, by the way, because I don't know whether they've seen it, but I think we have a break to actually set up the meeting in the convenience way. Now let me actually switch to what is the master itself. Okay, so let me start talking about what is the master program, and then we actually start the introduction later on. Okay, so moving on from general to specific, what do we study? What makes this master completely unique worldwide? And we pretend it to be completely unique worldwide. So it's not just yet another master in computer science and software engineering. There are several things. The first thing is the technical program. Okay, there are hundreds, thousands of masters in computer science. There are tens, hundreds of masters in software engineering. There are masters in management. There are masters in leadership. Okay, there is no master that put everything together. So as Sergey mentioned before, we do not need only technical people. We do not need only entrepreneurs. We need people who actually can face the new challenges of the future. And to do that, the technical challenges of the future, which are the main important one in our environment, you need basically not only technical skills, but we do need technical skills, and there are technical skills in this master. You don't need only management skill, but you also need management skills, and you have management skill in the master, and you need leadership skill. So there is a blend of these 3 areas, and you see we talk about quality engineering, we talk about data science, we talk about cyber protection, we talk about architecture, we talk about construction, software construction and architecture, we talk about dynamic analysis, deep learning, system protection. We will look at the new core elements of the computer science and software engineering discipline to actually get the technical background that will make you able to face the challenges of the future. We also look at vision, strategy, innovation, marketing, product portfolio, transformational changes, how to deal with this. Technical knowledge by itself doesn't go anywhere. I've not seen in the last 20 years anybody who starts without a team, without being able to manage a larger group. Okay, people start with an idea, people start by themselves. Second day, there are 2, 3, 4, 10, 1 million people, and you need to manage them. And also, it's not just a matter of managing, it's also a matter of leader. It's a matter of leadership, okay? So we talk about organizational behavior, entrepreneurship, agile leadership, customer-centric mindset. We have within our structures, leaders in psychology, in sociology, in team building, applied to technical stuff, to marketing, to business. Okay, this is the first part, and that's one part that makes the master unique. Now, can I switch to the next slide? Oops. Okay, I got the contract bank. Now, second part is the program, okay? We are offering you a Master of Science according to the famous Bologna Treaty Agreement. I hope you understand, in Europe, Master of Sciences are defined in a sort of standardized way. They actually are quantified in work that has to be, or that requires 2 years of study, and that's what we have. We have the classic program. We also have different programs. We have 2 different kinds of programs. We have the fast lane program. Okay, what is the fast lane program? It's very simple. A classic program, you have 4 semesters. You have work to be done in each of the semester. Usually, as most of the advanced and leading masters, we have the 4th semester dedicated to what is called master thesis, which is a full experience within the university, within research, within companies, within startups. So, and we'll see you later, master thesis here is not just yet another piece of paper that you submit. Is a research experience if you choose a research experience within our labs. Our labs here in Schaffhausen, our twin labs in the United States, in Asia, around Europe. It's not only that, it's also can be a unique experience in industry with our partners, with Acronis, of course, which is our main partner. With the Acronis group, Acronis has enormous amount of customers. You know, I mean, I personally enjoy car racing, and I was brought directly to the track to see the drivers on the track. Okay, not just you know, imagine we can do that. We did it. Okay, and also, we are starting, and we start a startup center. We have new companies in Schaffhausen like we are, you know, because it's actually in Schaffhausen with this virtual presence. But we do have RoboRace, which is a new company who actually deals with racing cars for only unmanned vehicles. Okay, which is a completely new advanced technology, which will be on the market soon. We will start new companies, and during the master, after the master, the thesis can be also an experience in that part, and this makes us unique. But you can also decide to want to go quicker to the market, and then you want to basically move the effort of the thesis partially in the second semester, full working summer, partially in the third semester, and finish one semester earlier than the 4 semesters. Also, you may want to be international. You may want to have a certificate. It is not just a sort of a European certificate, but you want a certificate from US, you want a certificate from Asia. So we do have partnership with Carnegie Mellon. We do have some partnership with NUS. We do have a double degree program that will allow you to get a second master or dual master. So you get a degree in Schaffhausen and a degree in US, or a degree in Schaffhausen and a degree in Asia. Of course, only for the people who actually can make it, only for the people who actually will be with us, only for all of you, and I hope all of you who will be able to actually go through the first semesters very, very quickly. I mentioned already the structure of the classic program. I don't want to go through that, but 1 semester, 2 semesters. The only novel amount here is, news here is internship. Okay, we do have partners. You can spend your time in Schaffhausen. You can spend your time in many of the different partners in summer to gain experience, maybe also to pair your pocket. Okay, and get the element. 2 elements which are important. You see, we do have classic programs, courses, technical courses, management courses, leadership courses in all semesters. Look on the bottom of the slides. This is another unique characteristics. We have 2 threads that span over 3 semesters. Thread number 1 is the Capstone Project. What is the Capstone Project? Well, the Capstone Project is hands-on experience. I studied in the last millennium. I found it very difficult to find experience. You know, I don't know if you believe that, but my first program was with punch cards. You know, the one you see in the museums. Okay, so basically what you did, you know, you were going to the class and learn, you know, imagine you can actually build a program. Imagine you can actually set up a system. Imagine you can actually run your program. Yes, you can do that. Punch your cards, go to the center, get the results out. Today is not just a matter of open your laptop and program, which is what we do every day in every course. It's a matter of, can we build something? Can we actually have an experience which is actually exactly what you get in a company, not just an internship, not only an internship, a real experience. Can we work in team, not just little examples, little programs done by yourself or little teams? Can we work in a team to achieve results? And we do have what we call the Capstone Project. We dedicate part of the work in the semester to work in a team. 1 team, 2 teams, many teams, depends on, you know, how we will organize. And we have a unique opportunity. We have an instructor who has 10 years experience in academia, 10 years experience in a company. An instructor who works with us, but works also with ABB, which is one of the leading company in Switzerland. And he knows exactly what is academia. He knows exactly what is education. He knows exactly what is user needs, industrial needs, company needs, teamwork, team activity. And he will be our leader in this project. And this is going to be spanning through the whole 3 semesters. Other thing which is also important, okay, we talk about the future. Quality engineering, software engineering, data science, deep learning, machine learning. Yeah, this is future now. We want to talk about quantum computing. We want to talk about advanced materials. We want to talk about new frontiers in management. We want to talk about new frontiers in security. We want to talk about techniques and technologies used not only in common times, but by secret services. How we do that? We have Future of Science thread. We will invite, we are invited, we have already a set of top scientists, Nobel Prize winners, Turing Award candidates, top managers will come in this virtual class and will share the experience with you. And this is not just an add-on, it's part of the program. You get credit, you get information, and that's what we are doing with that. Okay, first line we mentioned. You simply move the thesis in the summer and you take your chance. You actually work the whole summer, heavily, and get the master a semester earlier. Double degree, 2 semesters with us, and then you move to a Carnegie Mellon on NUS. I want to move to something which is a bit more like concrete, I guess you're sitting here and you say, yeah, that's a nice blah, blah, blah. How we actually start with grading, what it means to be excellent, what it means to actually access the program, what do I need to actually get to the fast lane, what I need to get to get my scholarship, okay? This question will be answered today and in the next days, okay? But let me give you one little key of understanding. We use the classic grading scheme in the northern part of Switzerland, which goes from 1 to 6. Okay, so 6 is excellent, 5.5 is very good, 5 is good. I mean, if you're familiar with ABCDE system in US, that ABCDE, okay, you're familiar with the German system, the old German system is similar. Okay, this is what we do. So we talk about X out of 6 in terms of grading that you actually need to get to pass. You need at least a 4 out of 6 to pass the exam. You need a 4 out of 6 to actually GPA to qualify. You need more to qualify for internship, to qualify for scholarship, to qualify for double degrees. Okay, so you need at least a 4 to stay with us. And we hope you all will stay with us. You all will get experience. You all will get education that will allow you to access the new job market that is opening in front of us. But, fast lane is very simple. We apply at the end of the semester, okay? And that's because the admission criteria is pass all the exams and plus with a GPA, which is 5.5 or higher, okay? Okay, so the GPA, accessing the fast lane is very simple. End of the exam session, we look at all of you. We see how many of you, hopefully all of you, had passed all the exams. We see how many of you, hopefully all of you, have passed with 5.5 or higher GPA. And then we ask, do you like to start the fast track, or do you prefer to take a good vacation and stay with the program because it's not required, but that's very simple. And then you say yes, and you get it, and then we work with you to give you the thesis, okay? Double degree now, let me actually say one little thing which is actually very important. The Schaffhausen Institute of Technology, SIT, is a new university. Okay, I guess you know that there is an accreditation process that actually makes a new institution a university acknowledged in the country. We started the process. The process is quite long. Okay, I personally applied 2 years ago to Swiss citizenship. I'm not Swiss citizen yet, and I still didn't finish my path. So Switzerland is Switzerland. You know, applications, certifications are important, are solid, are worldwide recognized, but they take time. So we will not be able to get the accreditation within the next 2 years. Okay, because that's the timing. We will get them later on. Okay, we believe that the big advantage of a master is what you learn. We believe, you know, Sergey before mentioned 2 people who actually started a small company, Google, which is big now. Okay, and he says they interrupted their PhD. They don't need a PhD to actually start a successful company, but you need education, you need knowledge. You know, he mentioned 2 things. They were student in Stanford and quit the PhD before terminating that. Okay, these 2 things are very important. You know, you need solid education, you need solid knowledge, ambition, and starting. Okay. And so we will give all of you the knowledge, the education that you need to enter the job market. Of course, you know, we will get a certificate, which will not be from an accredited university. So some of you may want to have a certificate which is from an accredited university. You get it if you actually get the double degree with CMU, because CMU will give you a certificate, a master in computer science in CMU. It's gonna be in NUS. We are also working hard with the University of Siena, Università di Siena in Italy. And we see whether we will be able to offer you also double degrees with the Università di Siena. We may actually be able to offer you other double degrees, not because we believe you get better or more or higher education there, but because you get a valid certificate. Okay, and some of you may be important. Okay. So double degree, the admission process is depends on the university. There are different admission processes. Of course, the requirement, which is true for the fast track, is also true for this one. So pass all exams with a high GPA. It's not only that, you will need to apply, you know, there will be an evaluation by the partner university. We will let you know during the semester what will be the requirements, what will be the deadlines. And the way we work is whenever there is an opportunity for our students, we tell all our students, there is this opportunity, please go ahead if you qualify. And you know, we want you all to work hard to qualify. Other unique characteristics, direct access to world leaders. Okay, this is the set of people we mentioned. I mentioned the Future of Science special initiative. These are the leaders we contacted to give you a vision of the future. Okay, we have Bertrand, who is a famous professor, who comes from ATH, who has a company who started a successful company in Santa Barbara in US, and he will be with us every week, every semester. Okay, but we also have exceptional people. We have Kostya, who is actually, as you mentioned, Nobel Prize winner. I think he's the youngest Nobel Prize winner in physics in the last century, at least, if not more. We have Arthur, who is one of the most important professors in quantum computing. We have Nicholas, who also is working in quantum informatics. We have Sergey, who is actually a leader in information and decision technology. We have Ilya, who is also leader in decision technology, decision processing. We have Yuri, who is in the area of the new materials. We have Anton, who is in management and data analytics, not just formulas. It's how we apply, how we use that in a real environment. It's not just a lecture, it's a direct vision of what will be the future, okay? Full-fledged experience, every university tells you that, you know, there is a job market. Every university tells you that there is an experience. Every university tells you that they have connection with companies. Some universities do have good connection with companies. We know the Silicon Valley is famous for that. This is the new Silicon Valley. Okay, we have Capstone projects. We work with the instructor from ABB, one of the leading company in Switzerland and Europe. We have a semester internship. We have $1 billion company hosting our students, Acronis. We have their partners hosting our students. We have companies in Schaffhausen hosting our students. We have startup thesis. This is unique. I've not seen it any other program that I know about, and I've been in the business for 30 years now, so I've seen many programs. Okay, you can do a research thesis, you can do an industry-related thesis. If any of you actually know about a university that offers you a startup thesis, just raise your hand and I'd like to learn it. A startup thesis means the thesis is create a company. Not just an exercise. Is to create a company, you need to have a great idea, you need to elaborate a great idea, you have a good technology background, you have to have a business plan, and you have to present it to our venture capitalist. Sergey is a venture capitalist also, and we have access to direct access to the top leading venture capital in companies worldwide. And we do have, we will have, I say we do have, because I know you were talking about the plans. COVID actually slowed down the building, the construction of the building here. So we are sitting in this sort of temporary location today, but we do have plans for a quick start of area for startups. And that will be, so the thesis is not just, I pretended to have been able to create a company, but you create a company. We have access to industrial leaders. Okay, we saw it today, Sergey, but not only. We have career opportunities within and outside our sponsors. Okay. I'm running a bit late. I don't want to give you much trouble about the break. The break is coming soon. Let me actually give you one little thing, information about the leading edge active teaching style, which will actually be experienced in the second part in the next day. So this is more like the blah, blah, blah that we experience tomorrow and the day after tomorrow and the week after, after this week and the week after again. Okay, which is this? Basically, I call it agile, flip, blended learning. Stanford uses flip learning. NUS uses flip learning. Some other universities using agile learning. No university uses blended learning yet. Now, you may be a bit skeptical given the trouble we have today, but today is the very, very first day, and you know we are doing our best. But we will have a Zoom room. That room for the few people in the class, you know, we will have it equipped with tables, with chairs, with physical chairs and virtual chairs. What is flip learning? Flip learning is make the best use you can in class. Means don't listen to the professor who actually repeats what you can study on a book. Means sit down, work with the professor and the TA to actually acquire the information, work in team in class. And this is what we will do. We will have you, some of you sitting physically in class, many of you sitting virtually in class, many more of you in class as soon as the visa problem and the COVID emergency will be over, working with us, working with the professor, working with the TA, who will actually lecture on demand to what we do not understand from books. Okay, and it's flip learning. It is agile because we will adjust to the situation. Like we did now, you know, we had a little trouble in getting all the images of you in the screen, and so we adjust the program, and that's what we will do. Adjust means, agile means, this is a known topic, skip it and go ahead. Oh, I thought you knew that, but you don't. Let's actually spend time on this one to get you the full education. And blended because, as I said, people are sitting virtually in the class. Okay, we hope to see you all, and we will see you all in Schaffhausen at least sometime during the master. Some of you every day, some of you every week, some of you every semester, some of you only a few times. Okay. Now, I have the schedule of the master, and I'll take really 2 minutes, and then I'll give you the break. Okay, the schedule of the master, it's very funny. Because, you know, you are used to this thick schedule with all these different courses, and it's, you know, it sounds, what is this? Okay, agile, that's the key issue. What it means, agile? It means that we have some courses which actually occupy some special time of the semester. So for example, the management course this semester will be given at the end of the course, will be given at the end of the semester, will be given in December and with a leg in January. Why is that? because we want you to acquire technical skills before and then management skill. Because we do have the vice president of APFL, the Polytechnic, the Federal Polytechnic in Lausanne, who will actually come and teach us management. He is an expert in management, and we needed to adjust to the need of a vice president to have him with you. And we prefer to have him with you rather than like an assistant to come every week. And then we have space to give freedom to the professor. So every course has 2 half days allocated. Okay, my course, quality engineering, Tuesday and Thursday morning. I don't teach 8 hours a week. Don't be really critical. But I do have space for 10 hours, 8 hours a week, so that I can actually occupy 0 hours, 1 hour, 2 hours, 3 hours, 8 hours, depending on what we need. Okay, so we start the first week. Today is Tuesday. We had the welcome lecture. I'll welcome you again at 2:30 this afternoon to tell you more about the program, talk about us. We have the software construction, architecture, and engineering course by Bertrand tomorrow morning, 8:30. We have my course, quality engineering, on Thursday morning. We have cyber protection on Thursday afternoon. And then every day, every week, we actually go ahead with that, okay? Now, it's time to talk about first semester and structure. It's time for a break. So we have a 15 minutes break. So a 10 minutes break, actually the director here says it's 10 minutes break. Okay, we have a 10 minutes break. Okay, you're welcome to get a coffee. The one who's not sit here may not get a coffee from our machine, but we want to, stay online, don't go away. So it's much easier, and we'll give you, we'll ping you in at 10:15. Of course, when we talk about time, time is actually sort of a relative phenomenon. Okay, but we talk about, we use the Schaffhausen time as a reference, okay? So 10:15 Schaffhausen time, 10 minutes from now. We have a sort of agile adjusting to the program, okay? I would like you all to introduce yourself. We started with the people in the classroom. Apparently, the way we actually structured the first lecture requires a bit of too much time to actually get everybody introducing himself or herself. So what we do is we move the introduction of all participants, all the students to the lecture this afternoon at 2:30. Okay, please remember, end of this lecture, we start again 2:30 Schaffhausen Swiss time. All of you are welcome in class again. Same link. We will actually have a different setup so we can actually see face by face. I feel a bit sort of nervous not to see my students on a face. I'm an old type of, I'm an old professor, so I need to see the face of the students, and we will do that in the afternoon. And because I think it's much nicer if you actually see the face when people introduce themselves and just getting like a sort of remote voice from somewhere. Okay, so I'm sorry not to actually to get this little change, but I think it's okay. So we move on with the first semester in structure and courses. So I think I gave you the overview of the master. Now the question is, okay, let's go into the details. What do we start for this semester? Okay, now I have some of the instructors are online, and they will introduce themselves and will actually present their course. Some instructors are not online today, and I will actually tell you who they are and give you some feeling about their courses, and you get more in the first class. So the first instructor is Alessandra, who I think is with us. Alessandra is a research assistant research professor at IMDIA. Okay, IMDIA is a new institute. It's older than us. It's easy to be older than us, actually, but it's not that old. It is the leading center for security in research and security in Spain. So it's a government institution, hosts the top leaders, hosts several ERC grant winners. I don't know if you are aware of that, but ERC is actually in Europe a sort of stamp of excellence for research. So let me give it in this sort of way. And they host several of them. Alessandra is with these great people. She's an expert in many things, actually. Alessandra is expert in testing, in software analysis, in automatic software repair. But more important, she's expert in malware detection for mobile applications, and she is the professor of cybersecurity. So if Alessandra is with us, we can handle the microphone to her. And welcome, yep. Alessandra.
Yeah, so thanks very much, Mauro, for the introduction. I think here it is pretty much everything. So like the very short introduction about my career. Indeed, as you can see, I'm not physically located in Schaffhausen, but rather I am in Madrid, where the IMDEA Research Institute is located. And yeah, as Mauro said, my background is mostly software engineering, but over the last years, I've been applying all the software engineering techniques on mostly on software analysis to the security and privacy research, mostly on mobile applications. And so basically these are my research interests. So like automation when it comes to software quality, like coming up with techniques on automate as much as possible the software testing activities, and on the automatic analysis of mobile applications to detect problems with security and privacy. I mostly work, I've been mostly working on Android, but recently I also got more and more interest in iOS, because this is a domain that really few researchers have been looking at. And yes, I mean, for what you actually care about, I'm the professor who's in charge of teaching the cyber protection course. And maybe you can go to the next slide, please, where I briefly tell you about the course. Okay. So I mean, the goal of my course will be mostly to provide your understanding of how you can protect and how you can build and how you can protect your system. The goal is basically to have the system that is completely protected from head to toe. So when you develop some software component, you typically focus just on your component, but the truth is that the system is built up on many different components. And when you think about cyber protection, you really need to think about the system as a whole. So the course will mostly focus on software security, but especially at the beginning, I will give you an introduction on all the different components that we need to understand in order to secure the system as a whole. So for instance, I will give you just a little bit of knowledge on network security, a little bit of crypto knowledge, but again, mostly to understand the implications for the main core of the course, that is software security. And in the course, we will mostly, so the goal of the course is mostly for you to understand what are all the possible vulnerabilities that may exist in software. And once you understand what are these vulnerabilities, then we can also look at the techniques that can be used to prevent them or can identify so that you can remove these vulnerabilities. And in terms of domains that we will use, we will mostly focus first on lower level vulnerabilities. So things that we should really care about when we look at backend systems, mostly written in C and C++. And then we will also cover more the front-end components, focusing on web applications, mobile applications, and so on. I think that's all I wanted to say for my course. Then Thursday will be the first class, and I'm really looking forward to meet you all, know more about your background, and start learning with you.
Okay, the next course I wanted, the next instructor I wanted to introduce is Thomas Moran. Thomas cannot be with us today because he's busy with a online conference. We have this funny situation that we are still busy with conferences despite not traveling right now. Thomas is a professor and at the chair of entrepreneurship and leadership in the University of Liechtenstein. Not far away from here, actually. So he's with us. It's very short one. He's an expert in leadership. He's an expert in leadership development. So, and I like the way he actually framed his expertise, which is his leadership development. I think there is this mixture of elements, which is not just like developing a leader. Because you do not develop a leader, you become a leader. It's not that developing leadership because it's not something that you learn, but you actually become. It's in between the two of them. You should get the leadership feeling to become a leader. And he is he's a famous expert of studies in human behavior in the context of enterprises. So his goal is to understand how people, they say there is a very simple question. You have a company, and you are the big boss of the company. And you really want to decide, you need to decide who is going to be the next CEO of the company. Okay, how do you do that? Two choices. One, you get the best CEO of the competitors and pay a fortune and try to get him or her coming to your company. Or you look at your people and say, who is the leader here? Who is the future leader here? This is what actually Thomas is studying, how we can actually understand the leadership skills of the people in a group so that we can actually get the best position for the people. It's not just choosing the best, by the way. It's not choosing the best. It's finding the best attitude. Some of us are leaders and play well the role of leaders. Some other are not leaders and would not play the role of leaders, and the contrary. So it's important to find the right solution. And he will give a course on, next slide. He will give a course on organizational behavior and industrial organizational psychology. If we get to the next slide, would be actually great. Okay, now it works. Why it's that? Okay, so I say Thomas is a behavioral psychologist. Now it's a big word to say what I try to explain you in plain words. Take it was my vision, because I'm not, unfortunately, a good psychologist. And so what happens is that I'm trying to actually rephrase with my wording what Thomas explained me what is his job, okay, which I hope actually gives much better information from him when the course starts. Okay, in the course, of course, I assume that not many in the class have a background in psychology, maybe some, you never know, but I think Thomas will give us, say us, because I personally attend this course. This is something that I really need to learn. Okay, so it gives you some information about basic principle of psychology. You need to understand something about psychology. Now, I think he moves on with cognition, emotion, motivation, and social processes. He will actually tell us what is how we describe the human mind in terms of this specific capability of the human minds, and then the second step is not just describing, but understanding, and by also comprehending, understanding. So the next step will be, how do we actually comprehend, understand what is the human behavior, what is the practical guidelines to actually select the personnel. So how do we actually not just learn in theory psychology, but use psychology as a tool to get the best out of our team. Okay. He will talk about organizational behavior, psychology. He will talk about psychology models to assess and predict the behavior. The question is how this person will behave in the future. He will talk about, how to actually influence the behavior of people in the organization. He will talk about organizing leading employees, teams, and units in the organization. Okay, this is the course. The course is actually a half course. Seems to be a lot, but is actually half in terms of amount of work to be done. But that's why I attended, because I have time for half half the course, not for full course, but that's actually a really, really nice idea. Now, Thomas, as I said, it cannot be with us today, so let's actually move on with the next speaker, because asking question to me about Thomas' course seems to be a bit bizarre. So you'll ask Thomas directly when he will actually start the lectures. Okay, Mark Gruber. Greg Gruber is it's not written there. Actually, it is the Vice President for Technology and Innovation of APFL. Okay, I thought I probably tried to summarizing highlighting the main things. I deleted that part. So that's actually the basic. He's also a deputy editor of the Academy of Management Journal. So basically, I don't know if you understand, but being editor, deputy editor in the case of economy, editor-in-chief in the case of science, is sitting on, being responsible of the editorial line of a major journal in the area. He is co-author of an influential book. He has and is professor of product vision, strategy, innovation, and marketing. So, as Thomas, Mark cannot be with us today, and so I'll also, as in case of Thomas, I'll take the lead here and tell you what the course is about. Okay, in one little word, and again, I'm using my wording. It's not actually, Mark wouldn't use the same wording because it would be much more elaborated. But my experience, different from Bertrand's experience, is you get a great idea, you get a great product, and you do not succeed or succeed. What is the difference? It's not the product, it's the vision of the product. Success and failure in industry, in the competitive world is not the best or worst product. Is being able to have a good product, hopefully the best, but not necessarily, and being able to build it. And build it means being able to understand what is the vision, the strategy, and the innovation of the marketing. It's not just like I have the best in the market. I can give you the feeling that it's the best of the market. Okay, so we talk about Mark will talk about managing exploration and exploitation organization. We'll talk about corporate road mapping and product vision. We'll talk about market opportunities. We talk about new development processes. We talk about building and managing an innovation portfolio, not just one single product, but a company, an innovation company. We'll talk about bridging technology and market. We'll talk about the decision in marketing. We'll give you one essential pillar to build your own company as a startup thesis if you go in that direction. Okay. Manuel, I think Manuel promised to be with us. Is he with us?
He is with us, yes.
Yes, he is us. So, hi, Manuel. So I don't have to actually spend my bad wording to tell you who you are, but you can introduce yourself. Thank you.
Yeah, it's usually terrible to introduce oneself, right? Because you cannot claim a lot, right? But maybe I'll try to do some work here. So I have been working in academia for quite a long time. I was teaching and lecturing at various universities, including ETH and University of York. And then 10 years ago, I made the move to an actual company, which is called ABB. You might have heard about it. It's a world-sized company, 120,000 people in the world. And I have been doing research, so industrial research for that company, focusing on various systems that they have. In terms of competency, I have worked in the software engineering field, software testing, software architecture, real-time systems, and one of my one of the points where I'm very proud of myself is to have worked on dynamic software updates, but not only for standard programs, but also in the case of real-time systems, and we were really the first people to do that. Currently, I'm working as an R&D manager, which is basically head of R&D for what is called application-based analytics, and this is basically it is a position that is focused on what is the new or one of the new trends in industry, which is Industry 4.0 in the case of, if you take the German terminology, but it's also IoT systems, so Internet of Things. And the idea is that we add to machines that were extremely conservatively made, motors, for example, electrical motors, we add some intelligence, we add sensors which are intelligent to them, and then we can forecast when they fail, and we make all the analytics that goes with this. So I have this dual track, academia and industry, a lot on the research. If you have a look at my record in DBLP, then you will see I have many research papers in various fields. And I am currently leading some Scrum teams that are actually delivering real projects. So maybe next slide. So the whole point of the Capstone project is to give you a real experience of what it means to have a potentially large project. So the idea is that we start with having requirement solicitation, with having some prototyping, with having some definition and so first designs that we will do. And then we move into active development. And of course, this is consolidating all the other teachings that you've had or you will have in the course of the master's degree that includes cybersecurity, that includes architecture, that includes real software engineering. The main point here is that we have to use tools, we have to code, and we have to make it work in the best manner. Being myself an expert in software quality, well, you will probably have requirements on this as well. So this is I mean, I'm very much looking forward to this course. I think it's a course that can make a difference for you. What I can guarantee is that you will use tools that professionals use. You will be able to actually ramp up in your knowledge of these things, and I think you will not regret it.
I think at this point, differently from before, if there is any urgent question and you can manage to wave your hand, we can give you the time. Otherwise, I'll move on with the next one and keep question for the next stage. No hand waving that I see. Okay, so next one is Bertrand again. So I give a hand to Bertrand to introduce himself again and the course.
As a for just as curiosity, this was the diagram of the countries, so you can see how diverse it is. And I also mentioned that that many students have degrees in fields other than computer science. And I hadn't presented a slide, but I guess some of you found it and filled it anyway. Thanks. That's the kind of initiative I like. And so you can see that we have a very diverse set of backgrounds. About the course, so let me say a few words about myself. Like the other speakers have done, I've been kind of hopping back and forth between industry and academia. So I could never really decide whether I wanted to be an academic or whether I wanted to be an entrepreneur and in industry. So I decided in the end that I would do both. I mean, well, it's like choosing between cheese and dessert, which to Frenchmen is the absolute horror. I mean, why would you have to choose between cheese and dessert? Why would you have to choose between academia and industry? So I taught that, I started in industry. I taught at the University of California in Santa Barbara. Then I started my own company, also in Santa Barbara. Then I was invited to teach at ETH Zurich in 2001. I stayed there, and now I'm at SIT, which is also kind of in between industry and academia. My field is software engineering, so I've covered a number of fields in software engineering, a number of subfields in software engineering. I've done work in programming languages, in software verification, in requirements engineering, in project management, and a number of other testing, and a number of other areas of of software engineering. Maybe before I say a few words about the course, I would like to ask Marco Piccioni, who is the TA for the course, and who I think is connected, to introduce himself. So could we switch to Marco? Or so I need to stop sharing? Or is it? No, can you switch to him? Yeah. It's not Marco Piccioni. It's also an Italian name, but it's definitely not Marco. But if you can just switch to him at the Zoom, I think it will work. If it's too complicated, we'll wait until the first lecture is tomorrow, so he will introduce himself then. But I think it would be nice to have a short introduction now.
Okay. Hi, everybody. So I will be a TA for Bertrand's course. My background is like I have a degree in mathematics, I have a master in economics, then I have 10 years experience as an education engineer in a software company, an IBM software company. Then I joined Bertrand at ETH in 2006, stayed until 2015. As I was there, I got a PhD in persistence of object-oriented applications, but then I got interested in education. Actually, I already was before, especially in online massive education. So we, together with Bertrand, we created a few courses that had they were successful in ETH first, and then in EDX. And so I stayed excited with online education, and then since 2015, I continued as a freelance educator, let's say. And so I'm looking forward to work with you. And yeah, see you tomorrow.
Great, thanks, Marco. So one important thing in what Marco said is that he was absolutely instrumental in our group developing some of the first MOOCs at ETH. Actually, I think it was the first MOOCs at ETH, MOOC meaning, of course, massive open online course. And so he was really the one who pushed me to record these lectures, these full courses, one on program construction, which we are going to use, and one on agile development. So altogether, it's 3 or 4 separate MOOCs. So we have, thanks to him, acquired a significant experience in recording video courses and in delivering them. And in particular, in our work at ETH, we developed an environment called CodeBoard, which is what we're going to be using at the beginning of the course, at least, which makes it possible to write programs on the web without installing anything. You just go to the web, to your browser, and you can write programs, compile them, run them, test them, and get immediate feedback. So we're going to be using this. So about the course, it started out, those of you who looked at the program of the masters about 2 months ago or earlier, saw that there was a software engineering course in the second semester. Then we moved it to the first semester for practical reasons, but then after running all these interviews with you, I realized that this was not enough, because I cannot teach software engineering unless there is a really strong basis in elementary programming and software architecture. So we changed the course into a 3-part course, which has 3 aspects: software construction, software architecture, and software engineering. Software construction is really about the basics of modern object-oriented software development, and we are going to go through the basics initially. So bear with me, because in some cases you will think you know all these concepts, but believe me, you don't. And I know this because I interviewed you on some of these concepts. So we need to establish a very solid basis of modern object-oriented software construction. That's what we do in the first part. And for that, we are going to use the Eiffel programming language, which is an object-oriented language which you should not find hard to learn at all if you know, for example, Java or C++, but it's more pure. As an object-oriented model, it really doesn't compromise with C, for example, like C++ does. So it's a very good environment to focus on the concepts, not on the language per se, but on the concepts. And you can install Eiffel Studio, which is the environment, if you want to. I will give you the instructions, but you don't have to, because you can do absolutely everything on the cloud through the browser. In the second part, we'll talk about software architecture, which is the set of techniques for building high quality, large software systems. We'll review, for example, things like design patterns that, again, based on my interview, some of you know a little bit about, but we'll go much more in depth, as well as into other techniques of software architecture. And then the third part is software engineering per se, which is the set of techniques for building not just programs, but software systems, including aspects like metrics, including project management. So we'll talk a lot in particular about agile methods, how to use them properly, what are their advantages, what are also their limitations, which is something that few people talk about. And in general, all these, also requirements analysis, which is a very important topic. You know, if you build a great system, it is the wrong system. If it doesn't satisfy your users, your customers' needs, you might just as well not build a system at all. So requirements engineering is about making sure that you define the system that you want to build. So these are all these software engineering techniques which go beyond programming and beyond software architecture. And this is a tall list for just one semester. So at some point, the pace might accelerate a bit because we have a lot to cover in one semester, but this is what you need in order to be completely fluent with fundamental software technologies for all the other courses that you are going to have in the curriculum, which require savviness and expertise in fundamental software technologies. This is what Marco and I are going to try to impart on you during the 2 months that follow, 2.5 months that follow.
And now we get back to the next instructor, which, if we can change the slides, okay, is one more, it's me. So eventually you got back to me again. Okay, so I'm, well, I think I already talked too much. You know, I mentioned before when talking about Mark that he is the deputy editor of a famous journal in economics. I am an editor-in-chief of one of the 2 top journals in software engineering. I mentioned with Mark that he's a co-author of an influential book in economy. I'm a co-author of an influential book in software testing. I'm not the vice president of APFL, by the way, so I have something different, but you know, there is something that I really actually I'm proud of. I graduated over 25 PhD students in my career, and many of them has a successful career in industry and academia. All of them have a successful career, many of them also in industry, and I will teach software quality. Now, if we go, let's see if I can move the slides. Yes, I can move it. Okay. I want to be short because I want to give you time to questions, you know, and I don't want to explain, but, you know, I'll tell you, I'll summarize the course in a couple of key words. We do have a lot of things there. One, I want to actually give you all what you need to become a quality manager. Okay, so if you want to actually be the software quality manager in your company, if you want to actually hire a good software quality manager, if you want to build a good quality team, that's what you need to know. Okay, and we'll see it through the course. Okay, the other thing which is important, you know, I'm working in testing and software testing, program analysis is creativity, is new ideas, is technology, is tools. And we'll see both of them. We'll see not only the theory, but we'll see the tools. And I will coordinate with Manuel to give you the chance to use some of the tools we introduce in the course in the Capstone project. So you see the theory, you see the tools, you see them in practice on the project. And I'll stop here with this because we are going over time. So we move to the next, which is question time. Now, let me give you a framework and tell you how we can try to work. Okay, so framework is the following. Now we have question time. Given the current setting, what you need to do, you need to wave your hand. I think it is possible to do that. Whenever you wave the hand, the technical staff here will switch the microphone to you and can ask questions. Couple of information while waiting for the first brave people to ask questions. Okay, one information is that we end in half an hour. We resume at 2:30, as I mentioned several times. Same link, different Zoom settings, so we will actually be able to talk each other. I will ask you to introduce yourself, and we have time for more questions at that time, and we talk about the learning management system at that time. Second information is, unless there are already questions on, I try to actually answer the first question because I think it's going to come anyway implicitly, okay, unless there are questions already in line. Yes, I asked that. Okay, while you raise your hand to ask questions, I answer the first question, which is has been in the air at least here forever, which is what's next in terms of program, in terms of studies, in terms of scholarship, in terms of future of the master. So I'm sure that this is in your mind. Okay, so what's next? You are all, and I'm talking to the students. I actually take out myself, Bertrand, and a few people who are not students in this classroom, in this virtual classroom. You are all registered to the master. Okay, so you are master students. Okay, admitted to the master. You're all admitted. At the moment, we need to still decide. A final decision about assigning the scholarship. Okay, so I like to clearly sort out this point because I think it's going to be the urgent question for most of you, and I understand because it would be mine if I were a student. Okay, so we have students, and you know that the fee is 5,000 francs per semester. Okay, we have students who get exemption from the tuition fee. Okay. There are two possibilities. The first one, okay, well, if you pass a semester and you get a GPA greater or equal 5.5, next semester, the following semester, you are exempted from the fees, and this is cumulative. So if you keep the GPA above 5.5, you get exempted from scholarship for the whole semesters. There is one exception. If one only semester you get down to 5, you still keep the exception and it continues if you get up to 5.5. That seems to be simple. Other possibility, some of you may be admitted with a tuition fee exemption. Okay, we are still working with admin because I hope you understand there are two bodies here, as in any university. There is the pure academic body, idea and no money. Okay, this is me. And then there is the economic body, which is governance, management, and money. And that's a different body. And I wish I could give scholarship to everybody, but I need to go through this. And so we need the final process. So we are almost there, but we need, and the reason why to be late is because I want to push for getting more scholarship. So I prefer to wait a bit more and give you a hard time waiting rather than going ahead with soon. But soon you will get it. So no scholarship, the first option. Exemption for tuition fee every semester after the first, of course. Some of you applied and may get exemption for the first semester too. So some of people can start with the no fees. You maintain the privilege of no fees if you keep the GPA, same rule, 5.5 with one exception to 5. Okay, all exams don't, by the way. Okay. Another type of scholarship is what we call full cost scholarship, which means you get a fixed amount to live in Schaffhausen. We believe that learning is not only sitting physically on a table, but learning is also sitting together. We believe that we can sit together remotely and we should learn that, but we want some of you to have the chance, the opportunity to come here in Schaffhausen and sitting with a few of you who are already here, fortunately. Okay, and so we have this, we cannot support everybody, but we can support many of you with a scholarship to come to Schaffhausen. Now the scholarship is will be assigned very shortly based on the result of the many interviews that Bertrand did. We mentioned more than 100 interviews in the last 3 weeks. Just to make sure that we understand, full scholarship will be given to a selected number of people, will be given in terms of money At the time, the student will be able to move to Schaffhausen. So we do not give money to students to study remotely, so you can opt to study remotely, but you can come to Schaffhausen and be with us from the moment that COVID, visas, your family, your whatever allows you to come here with us, you'll get the scholarship, okay? And the scholarship is maintained with the same rules. GPAs greater than 5.5 with one single exception and all exam passed, okay? Then there is a fourth, well, maybe fifth type of scholarship. During the semester, you will be notified for the rules and regulation to be admitted to the double degree if you like to be admitted to the double degree with CMU or NUS. We do have few scholarships that cover both the tuition fees and the living cost in either Pittsburgh or Singapore, okay? So to apply for this scholarship, you need to qualify according to the rule of our rules, all exam passed up to the point, average. So passing exams, attending exam, getting a high grade is a requirement. And then you will actually have also to satisfy or to follow the selection criteria of the committee that is defined by the host institution, because we have this mutual agreement. We host students in Schaffhausen from other universities and we select them. Our partners host our students in there and they actually help us selecting them. Okay, I hope I answered the first question. Maybe there are other questions. Yes. Okay. So this is the order. So I think it's a Kiev. Okay. Okay. Okay, we have few people in line. We have Kiev Mintant online. Kian, may I ask you to turn on your microphone? So you should unmute. Yes, please. I would like you to tell us who you are. You know, just introduce yourself and then ask a question. So who you are, what's your degree, where you got the degree, where you live, and what the question is.
Hello, I'm from Myanmar. My name is John Mintant. I got a Bachelor of Computer Science in Myanmar. Yeah. Have a nice day, guys.
Okay, welcome to the master. Ask your question.
Sorry?
You have a question?
Yeah, if I get 5 or more in the semester, can we get a tuition waiver for the coming semester? In the semester, if we get only 4, can we still maintain the semester tuition fee waiver?
Okay, the microphone here is a bit noisy, so I think let me repeat your question. I hope so. Are you asking whether the tuition waiver exemption is for all people, regardless whether they are in Schaffhausen or not? Is that the question?
Sorry, can you hear me? Can you hear me?
Can you give me the microphone to speak now? Can I speak? Yeah, I can hear, but he asked me to actually reply. If I speak, okay. I don't know if you can hear me. I hope so, because I don't have control on the microphone here. Okay, let me answer the question, and then maybe if the answer is not the right one, you can repeat the question. Okay, so you were asking about scholarship for tuition waiver. Okay, so they are given to students regardless of their physical position. So you get the tuition waiver if you are sitting in Schaffhausen or if you're sitting anywhere else. In Vietnam, a lovely country. I've been there last year actually. It's a fantastic country. And that's one possibility. So if the question is whether you have any need to be in Schaffhausen to get the tuition waiver, no, you get them no matter where. The second part is tuition waiver starting from the second semester over are only bounded to the performance in the course. So if you actually pass all exams with the GPA greater or equal 5.5, you get exempted without other applications. For the first semester, we will communicate the one of you who get the tuition waiver. Nobody so far, as far as I understand, received any request for money. So we will send the request for money only when we will have decided for the scholarship. I hope I'm correct. Does it answer your question, Kyat? And if you can repeat your name as well, I can actually learn it. Okay.
Hello.
Okay, so I got, yes, I got a repetition, which is, so you ask if you get less than 5, if you get 4, the tuition waiver is not applied. So basically, first semester depends on the decision. Second semester depends on 5.5. Third semester, you can get a 5, but no less than a 5. Fourth semester, you either go back to 5.5 or you can get a 5 if you get a 5.5 in the second semester. So basically, 5.5 all semester, except one semester, 5. Less than that, the tuition waiver is out. Does it answer now? Hope so. We have one more question from Salim. Salim, unmute your microphone and introduce yourself and ask your question.
Hello, my name is Salim Shibli. I'm from Syria.
Welcome. Okay, your question is?
My question is, here in Syria, we have a situation that there's no electricity sometimes or no internet, so we may have a problem to listen to lectures online. Can we attend it offline, like maybe an evening or something, before we get the scholarship, if we get it?
Okay, thanks a lot for the question. This is actually some topic that I wanted to address at some point. Okay, which is, the question is whether it is possible not to attend all classes, but attend classes offline. Okay, now the answer, the simple answer is yes, if they're absolutely required. Let me give you the more complete answer, okay? We require you to be in class, not because we are sort of, how can I say, pretending, but because we believe that the class experience is important. We'll see this afternoon with a different setting how we can actually interact a bit more fluently. I think we believe that we want to experiment this. We want to actually give you the possibility of hands-on. Now, hands-on offline is a bit difficult, okay? We do understand that some of you may have some issues. You know, you mentioned the unfortunate situation that you suffer in Syria, a country I did not visit and I wish I could visit at some point soon. Of course, we understand that depending on the country, you may have problems in terms of connectivity, in terms of ability, also in terms of time zone sometimes. So if it is really impossible to participate to a class, we will offer a lot of material offline to actually try you to catch up, because, you know, it's because of that. It's also because of COVID, you know, I don't want to actually assume that we are unlucky, but it may be possible that some of you for some time may not be able to actually work properly. Of course, you know, if you don't work for the semester, you cannot pass the semester, but we'll try to help all of you to catch up with the classes so we can actually give you the possibility. Most of the material will be online. We record the classes online. We will do our best to offer what we can offline, and we do our best to give you the opportunities to be online, but if impossible, we will actually work with that as well. Other questions? Yes, oh yes, sorry, I'm so bad. We have Eliu.
Yeah, hello, good morning, everybody. So my question is, if you don't get this, for example, if you don't have the tuition waiver, for example, can you still apply for the fast track or the double degree programs during the first semester?
Okay, thanks for the question. May I ask you to introduce yourself, you know, pronounce your name so that we actually start learning, and tell you where you are and where you graduated, and then I answer the question.
Okay. So my name is Aliyu Alege, and I'm currently in Nigeria. I graduated I graduated from Kazan in Russia, where I studied chemical engineering, but I've been working for the past 2 years as a software RPA and AI engineer in Lagos, Nigeria. Yeah.
Okay, thank you. Now, your question was about, if I understand correctly, the fast track, correct?
Yes.
Okay,
yes.
and okay.
And double degree.
And double degree. Okay, so fast up applications are sort of more than application acceptance. So end of the semester, first semester, we get the list of the students who passed all the exams and with a GPA higher or equal 5.5, and those students will be offered the opportunity to start the fast track. So it's an option that you have if you pass all the exams first semester. Now, this is the very, very first time we started this master. This is the very, very first time we implement this fast track. I mentioned that we adopt an agile approach, so it may be the case that we actually sort of stretch a bit the limits. Okay, but the idea is you shall be do your best to be the best student in the first, or among the best students in the first semester to be able to apply to the fast track. It is because we believe that the fast track is an extra effort that is difficult to sustain if you're already late with the exams, if you are struggling with some exams. So we actually give the opportunity to all the students who actually can be, in our understanding, work well in the fast track and succeed in the fast track to apply. Does it answer your question? You turn the microphone on if you want to. Aliyu, can you turn on your microphone and tell us whether it's a good answer or you have other question?
Yeah. The second part of my question is actually not answered yet. What I was asking actually is that can we still apply for the double degree program if we don't get the scholarship now?
Oh, sorry. I'm getting tired of this long thing. I remember the first part. I just came on trying to get on. Yes, for the application for the double degree, we will let all students in the classroom know when and how to apply. We do not have classic information yet because we have had experience with CMU and NUS already for 2 generations of students. They did very well, but we have seen with the partner universities that they do have minor changes from year to they have a sort of fine tuning of the admission process. So in the past, the admission process was based on the documents, that the usual documents, letter of intent, curriculum, performance, and in interview with some interviews with people from SIT and from NUS or from CMU. But this year it may slightly change. So we prefer to give you the exact deadline and the modalities when we have them completely. So if you stay with us, you work with us, you get an opportunity to get this information, okay? Unless, Aliu, you need other information, I'll switch to Amhad. So Amhad Valinori, can you actually introduce yourself, unmute, introduce yourself and ask your question?
Hello, sir. I'm Ahmad Wali from Afghanistan. My question, if a student selected for a scholarship, then move to the SIT university or in a country? And second question, the test or exam, the first semester online or move to the SIT university?
Okay, I answered the second question because I didn't understand the first one. Let me start with the second and I'll ask you to repeat the first one. Okay, the second question is about exams, okay. Of course, we have, if students are sitting worldwide, it makes no sense to have all of them in Schaffhausen for the exams. We hope to get some of you in Schaffhausen, many of you in Schaffhausen. It's the option to come to Schaffhausen for the exam is always open, but we will set up the evaluation criterion so that you can be evaluated also without coming to Schaffhausen. By the way, I want to actually make another observation. We instructors with professors will have a different way of evaluating students. Okay, so I personally believe that students cannot be evaluated one shot only at the end of the course, and so in my course I will actually implement a way of evaluating students which is actually a rolling evaluation through the course. You get a sort of incremental evaluation, and there will not be a sort of big exam at the end. Okay, but this is my course. There are other courses, other instructors. Each course has a different attitude. In all cases, we will make sure that we will be able to actually get the evaluation, the exams, all the evaluation process available online and on site, both of them. Now, Ahmed, can I ask you if I answer the second question, to repeat the first one?
Second question about the online test. About the online test, or my main is the first semester, the final test or final exam is online, or move to the SIT university as student?
Okay, both. You will be allowed to actually do it at SIT, but you can do it online without moving. Okay. I'm checking whether we have other hands raised. Okay, we have Debrinas, Zacharias. Sorry for my bad reading. The setting is not perfect. Zacharias, may I ask you as usual to introduce yourself so I can learn how to pronounce your name? Tell us your degree, where you are, and then ask the question. Unmute yourself. Great. Go ahead.
Okay, all right. Thank you for the opportunity. It's really an honor to be the part of SIT's family. My name is Acronis from Ethiopia, and I have already been graduated with computer science and engineering last year, and currently I'm working as a software engineer at a company called Paga. And my question is the scholarship that will grant students to come to SIT Schaffhausen, and so we will still be affected with a high grade criteria after we came there?
I'm not sure I got the full question because the microphone was full, was very disturbed. Did anybody understand, or may I ask you to repeat the question? The microphone, your microphone, maybe you are, I don't know whether you're too close or too far, but it sounds a bit bad. May I ask you, sorry, to repeat the question?
Okay, sorry for the distortion. My question is, it's all about the scholarship that you told us. The scholarship that grants students to come, to relocate to SIT and attend the class physically. So will it still be affected or imposed with high grade criteria? Do we have to score a high grade? That means 5.5, greater than 5 or 5.5 in every semester? Is that mandatory?
Okay, let me try to answer. I hope I understood this was much better now, the sound. So the question is about the criteria to get and keep the scholarship. So we will decide about scholarship in a matter of, I don't want to say hours, but days. So you will get a notification, all of you, about which scholarship, if any, you get. And this is going to decide that now, regardless of the GPA. To maintain the scholarship, no matter which, you need to satisfy the academic criterion, which is GPA, all exam passed first semester, GPA greater or equal 5.5. Okay, no matter which scholarship or where. Otherwise, this is the condition to continue maintaining the scholarship, no matter whether it's tuition waiver, whether it's actually full scholarship, whether it's to actually go to an US or CMU. I hope I answered your question, and unless I actually I have, and now let's see, in my list here I see Akshay Gupta.
Hello, Professor. I'm Akshay. I'm from India. And my question is regarding the course and how we are supposed to be attending it. In terms of that, are we allowed to continue with our full-time jobs while continuing this course, or are we supposed to be full-time available and online for the course and can't work as is the case with other universities?
Okay, that's also another question that I was expecting. As I mentioned, and I think it's important to repeat it, thanks for asking them, being in class is important. You know, it's not, this is not like a classic MOOC, which is great, but you know, it's something more, hopefully. So, you know, simply attending offline does not give you the full experience, okay? So, that's the first part. So attending classes is important. Classes are not scheduling 8 hours a day every day, but they are scheduled depending on the time. So there are times where they are scheduled more or less. We have most of the students from the, let's say, Europe and East, well, let's say the Eurasia and Africa continents. We don't have many from the Americas, which means that we try to schedule the classes early time in Europe so that we don't get too late in other parts of the world. Depending on where you are, of course, you may get classes also in the late afternoon. Working is a need for many of us, and of course, you know, is possible during the master. It's not that it is incompatible, but you should try to find a trade-off to be able to find the time to attend the classes online as much as possible, because there is a big risk not to be able to complete the degree otherwise. So we are not asking anybody to quit their job if they have a job, but if the experience is just offline, is not enough to actually stay with us. Okay, I have again Bertrand who wants to add something.
Let me complement Mauro's answer with respect to my course. So in the software construction, software architecture, and software engineering course, we have the benefit of the MOOCs that I mentioned earlier. That is to say, the courses that have already been recorded. So the way, at least at the beginning of the semester, the way it's going to work is the following. Each lecture on Monday and Wednesday is going to be divided in 3 parts. First part is the MOOC, second part is a lecture by me, and the third part is a lab session by Marco Piccioni. And so for the MOOC, this is something that, so let's say it's 8:30 to 9:30, 9:30 to 10:30, 10:30 to 11:30. It might change a little bit, it might actually move by half an hour, but that's roughly what it's going to be. And so for the first part, basically you have to take, to listen to the MOOC lecture. And so that you can do at that time, say 8:30 to 9:30, but you can also do it anytime before that. What I'm expecting is that when I start my own interactive lecture at 9:30, you have taken that particular MOOC, that particular lecture, otherwise you're going to be completely lost. So I come at 9:30, maybe I will show a few supplementary slides because not everything is in the MOOC. Maybe I won't, and I will just be there waiting for questions, and it's going to be, if you like, a kind of Socratic lecture in which we interact, we talk to each other. So this is again why it is so important to have a good microphone, a good setup, because otherwise it's not going to work. We're going to waste our time in communication issues. Do you hear me? Can you repeat, and so on. So it's really important. But so the second part is completely or partially interactive. I'll show slides and I will interact with you, and this is your opportunity to ask questions. And again, it doesn't make sense unless you have taken the first part, which is the MOOC. And then the third part is like my lecture, but it's the lab session with Marco, and it's going to be even more interactive. And so in terms of the load on your schedule, for the first part, you can take it any time before, so it can be very flexible. And you know, by default, you take it 8:30 to 9:30, but it can be at any time. For the second part and the third part, you have to be there, otherwise it doesn't work out. This is just for one course, you know, mine. Each lecturer is going to organize his or her own course as they want. But this is one scheme that I hope is going to work well, and it's a way, if you like, to combine the best of recorded information, which we are fortunate to have in the case of this course, and interactive sessions using Zoom.
Okay, I have Vlad, Michael, and Sasha registered for questions. It's almost 11:30. I think we had a very long this morning. So my suggestion is the following: we conclude the session now. We'll resume at 2:30. Repeat once more, same Zoom link. You get notification for any change. Different Zoom setting. You don't have to worry, but it's going to be much easier to interact, hopefully. Okay, I'll keep Vlad, Michael, and Sasha on my waiting list for questions. We will organize the afternoon session so that we go through the questions in introduction, and then we go for the introduction later on for the other people. Okay, I hope it's clear to everybody. I'd like to thank you all for being patient, listening to my voice for so long, even be able to actually work around the little technical problems we had. And I'll see you all in exactly 3 hours, in exactly 3 hours at 2:30 afternoon European Central Time. Thank you very much. And Vlad, Michael, Sasha, remember you write your questions so you start next session.